guys, so we are the group for today that will be discussing electric potential. So for our group members, we have Valencia Marinel B, Baldicano Kelly E, Gregorio Nerlina Amor, Baloyo Marcus Damian O, Bailen Princess I, Boquiron Lex Matthew, Concepcion Rose Micaela, Londres Drex Yuri, and Sariel John Terrence. Let's start with the electric potential energy. So let's start. So did you know that GPE or gravitational potential energy and EPE or electric potential energy has a similarity? For example, these two pictures that you see on the PowerPoint, the first illustration tells you that may isang bola or object na nasa taas kung gaano kataas ang isang bagay, the more it contains high potential energy, and let's say na it's a maximum gravitational potential energy. Once na nilet go natin yung object na or yung bola, it will fall to the ground and it will accelerate all the way down. The gravitational potential energy will transform to kinetic energy once it falls down. So basically, the ball has gone through a change in energy from one form to another. So it's the same concept sa electric potential energy. So let's say sa illustration number 2, you have a positive charge, yun yung kulay red na bola, near the positive plate in an electric field between two parallels. So, same concept na nasa taas yung positive charge and containing a maximum electric potential energy. So, once you let it move, it will repel to the positive plate and mapupunta siya sa negative plate, which is the black rectangle na makikita mo sa PPT. And again, it will accelerate all the way down hanggang makapunta yung positive charge to the negative plate. And by doing that, nagbago yung electric potential energy to kinetic energy. So, same concept lang katulad ng bola or object sa illustration 1, it has gone through a change in energy from one form to another. So, gravitational potential energy and electric potential energy are quite analogous. A charge accelerated by an electric field is analogous to a mass going down to hill. In both cases, potential energy decreases as kinetic energy increases. So, what do you mean by analogous? So, analogous means like similar or comparable. And so, yeah. So, when a free positive charge Q is accelerated by an electric field, it is giving kinetic energy. So, makikita mo siya sa picture na the positive charge, yung blue na ball, going to the negative plate. The process is analogous to an object being accelerated by a gravitational field as if the charge were going down an hill, where its electric potential energy is converted into kinetic energy. Although, of course, na the sources of the forces are very different, but the concept here is the similarities of GPE, or also known as gravitational potential energy, and EPE, also known as electric potential energy. So, yeah, thank you.
Electrical potential energy is the energy that is needed to move a charge against an electrical field. Imagine that you have a huge negatively charged plate with a little positively charged particle stuck through the electric force. You take the positive particle and start to pull it off the plate against the pull of the electrical field. It's hard work because the electric force is pulling them together. However, if you pull the positive particle further away from the plate, you would have to use more energy, so the charge would have more electrical potential energy stored in it. The energy that you use to move the particle away from the plate is stored in the particle as electrical potential energy. Electric potential energy is the energy that is needed to move a charge against the electric field.
For the formula in computing the electric potential energy, there are two formulas. The first one is a formula for the 2-point charges, and the second one is for the charge in a constant electric field. For your 2-point charges, the formula is EP is equals to K times Q sub 1 times Q sub 2 divided by R squared, where EP is the electric potential energy in joules, K is the Coulomb's constant, Q sub 1 and Q sub 2 are the charges in each body in coulombs, and R is the distance between charges in meters. For the second formula, For finding the charge in a constant electric field, the formula is EP is equals to QED, where E is the electric field in newtons per coulomb, Q is the charge that experiences the electric field in coulombs, and D is the distance from location chosen as EP is equals to 0 joules meters. Here is a sample problem. How much work is required to bring together the three given charges from infinity to the corners of an equilateral triangle of side length 1 centimeter? The formula that we'll be using for this problem is U is equals to K times Q sub 1 times Q sub 2 over R, where U refers to the potential energy of the object in unit joules, K refers to the Coulomb's constant, Q refers to the charge of the point particle in unit coulombs, and R refers to the distance between charges in meters. And for the given, Q sub 1 is equals to 1 microcoulomb, and it's equals to 1 times 10 raised to negative 6 coulombs. And for Q sub 2, it is equals to 2 microcoulombs, equals to 2 times 10 raised to negative 6 coulombs. And for Q sub 3, it is equals to 3 microcoulombs and equals to 3 times 10 raised to negative 6. And for the K constant, it is the Coulomb's constant. And for lastly, the R is equals to 1 centimeter, or in meters, it is 0.01. So here's the solution and answer. For step 1, since the work done to assemble the charges is equals to their potential energy in this arrangement, we will find the potential energy between each pair of charges, while work is equal to change in potential energy. Since the charges start at an infinite distance, initially potential energy is equals to 0. For charges 1 and 2, work is equals to K times Q sub 1 times Q sub 2 divided by R, which is equals to the Coulomb's constant times 1 times 10 raised to negative 6 multiplied to 2 times 10 raised to negative 6 coulombs. And the answer for this is 1.8 joules. And if we combine charges 1 and 3, the work sub 13 is equals to K times Q sub 1 times Q sub 2 divided by R, which is equals to Coulomb's constant times 1 times 10 raised to negative 6 coulombs multiplied to 3 times 10 raised to negative 6 coulombs. And the answer for this is 2.7 joules. And if we combine charges 2 and 3, the work sub 23 is equals to K times Q sub 1 times Q sub 2 over R is equals to Coulomb's constant times 2 times 10 raised to negative 6 coulombs times 3 times 10 raised to negative 6 coulombs. And the answer for this is 5.4 joules. And for the step 2, we are going to add together all these potential energies to find the total energy of the arrangement. So the solution for this is that we will combine all the charges, which is the work, which is the Q sub 1, Q sub 2, and Q sub 3, which is 1.8 joules plus 2.7 joules plus 5.6 joules. And the final answer for this problem is 9.9 joules.
Let us now discuss the electric potential. First, what is electric potential? The electric potential is the property of position, not of an object. The electric potential at a position is the number of joules that would hold a 1 coulomb located at that position. Electric potential is a scalar quantity. Its SI unit is volt, which is named after Alessandro Volta, who devised one of the first electric cells. The electric potential or voltage is the difference in potential energy per unit charge between two locations in an electric field. The electric potential is a measure of amount of potential energy per unit charge. It is the work done per unit charge in order to bring the charge from infinity to a point in the electrostatic field against the field force. So as a particle moves between two different points in space, an initial point and final point, the potential changes and the potential difference represents the energy gained or lost per charge in the move. So the electric potential at any point in an electric field E is electric potential energy per unit charge at that point, and electric potential is designated as V. It is measured in volts. 1 volt is equals to 1 joule per coulomb and is a scalar quantity. Electric potential is the push of electricity through a circuit. It's easy to confuse electric potential with electric current, so it helps to think of electric current as the water in your shower and electric potential as the water pressure. So like water pressure, varying voltage can increase or decrease the flow of electricity.
This diagram shows the forces acting on a positive charge located between two plates, A and B, of an electric field. The electric force exerted by the field on the positive charge is to move the charge from plate A to plate B. An equal and opposite force must be applied. The work done is moving the opposite charge through a distance. Potential energy for positive charges increases when it moves against an electric field and decreases when it moves with the electric field. The opposite is true for a negative charge. If an electric field has a force per unit charge, then by analogy, an electric potential can be thought of as the potential unit per charge. Therefore, the work done in moving a unit charge from one point to another is equal to the difference in potential energies at each point.
So dako naman tayo sa formula sa pag-compute ng electric potential. So balikan muna natin ang definition ng electric potential. Ang electric potential, this is the amount of work or the amount of energy that is needed to push a charge from one reference point to a specific point. Looking at the formula, this is a simplified version of that statement. So V will be the electric potential, and this will be, the unit will be in volts. That's why it's denoted in V. Electric potential energy, this is the work, this is the energy that is needed to push the charge from one reference point to a specific point. And this will be in joules. Q naman, this is the charge that will experience the potential. This is the charge that will be pushed by the work to one reference point. From one reference point to a specific point. And this will be in columns. So, kung mapapansin nyo, pag ang joules dinivide nyo sa columns, magiging volts yan. Let's look into the superposition principle. Okay. So we have two formulas here. V equals to V1 plus V2 plus V3. Okay. And then the other one, which I do not need to state. So before I explain what this is, okay, I want to give the definition of the superposition principle and how it applies for this case. So the superposition principle, it states that the net response caused by two or more stimuli is the sum of the responses that would have been caused by each stimulus individually. So what does that mean? I want you to think of it as position 1, position 2, and position 3. Or rather, situation 1, situation 2, and situation 3. Okay? I want you to think of them as coexisting at the same time or happening simultaneously or at the same time. So why do we need to add them up? Why do we need to add these positions up? The reason why we add them up is to get the absolute position, right, of the charge within the electric field, where it's going to end up. Okay, so that's why the superposition principle is really useful for this. I want to give an example about one thought experiment by Erwin Schrödinger, the late Erwin Schrödinger. It's called the Schrödinger's cat. Okay, so we have this box, we have a radioactive element, and we have the cat. You put the radioactive element and the cat both inside the box, and you close the box. Now, any ordinary person would think that the cat is dead because of the radioactive element. But think about it this way. Think of it as two situations, right? Because the cat can be dead and it can be alive. But think of it as it can be dead and alive at the same time. Until we open the box, that's when we know the result, right? So within that box, think of it as two states are happening at the same time. We can use that for this situation, for this case. So tingnan natin itong sample problem. Okay. Find the electric potential at a point located midway between the charges when both charges are positive as shown. So ang given natin is Q1, which is equal to 2.5 microcoulombs, which is also equal to 2.5 times 10 raised to negative 6 coulombs. Ang K natin, this is the coulomb constant, right? So we've been using this to add the topic. 9 times 10 raised to 9 newtons times meter squared over coulomb squared. And yung radius natin magiging 1 meter since yan ang kalahati ng 2 meters. So anong gagamitin natin formula? Ang gagamitin natin formula will be V equals to the constant times Q over R. But since dalawa po sila, we will just add them up. So K times Q1 over R1 plus K times Q2 over R2. But think of it this way. It is just the same idea as 2K times Q over R. So yan ang gagamitin natin here. And keep in mind that R1 and R2 are the same, which is 1 meter. And Q1 and Q2, which are the charges, they are the same. They're both positive 2.5 naman. That's why we are able to use this modified formula in a way. So 2 times the constant, 9 times 10 raised to 9 newtons times meter squared over coulomb squared times 2.5 times 10 raised to negative 6 coulombs, so over 1 meter. And yung answer natin magiging 4.5 times 10 raised to 4 volts.
Now, let us move on to the electric potential difference. Spot the difference. There are two pictures on the slide, and you might notice that there is a difference between the distances or compactness of the particles. We all know that potential difference is always measured between 2 points. So when there is a potential difference between 2 points, this means that the charge will tend to flow from one point to another. In this example, specifically the left one, the bunching up of electrons that repel each other means that there is a potential difference between the left end and the right end of the conductor. This means that there is causing them to flow from a particular direction, kaya nandun sila sa left, if you can see the direction of the bunchedness of the electrons. So for the left one, in this case, once the electrons have moved and spread themselves out, there is no longer anything causing them to flow in any particular direction. So once this has happened, there is no longer a potential difference between the ends of the conductor. Basically, the current always moves from higher potential to lower potential. So in order to create electricity and maintain the flow of the current, a potential difference is always required by the battery or a cell. So this can be seen in the left picture, since nakita natin na yung mga electrons, they moved from the right side to the left side. Dahil yung sa right side, mas mataas yung potential doon, and then yung sa left side, mas mababa yung potential doon. So that needs to be done para magkaroon ng balance at ma-maintain yung flow ng current. So that means that there is a potential difference in that specific picture compared to the other one. Let us now dig deeper about what electric potential difference really is. So, electric potential difference between 2 points is simply the energy required to transport a unit charge between those 2 points. It is measured in volts. 1 volt is defined as 1 joule per coulomb. It could also be defined as the change in the potential energy that occurs due to transport of a unit charge from one point to another. Whenever electrons are being made to move from one point to another, we can say that there is a potential difference between these points. In other words, potential difference describes how hard electrons are being driven from one point to another. Electric current flows from a point of high electric potential to a point which has a lower potential. It is just like the behavior of water that always seeks its level. current flows between 2 points that have a difference in electric potential to balance this inequality, just like what I have said earlier. So as the current flows between 2 points, every charge gains energy that is equal to the difference potential between them. Two terminals of any battery have a potential difference between them, which is measured in volts. When you connect any circuit between the two terminals of the battery, charge flows from one terminal to the other to equalize the charge imbalance and continues till the difference between them is equalized. As what you can see on the lower left side of the PowerPoint, the longer side represents the higher potential and the shorter side represents the lower potential of the battery cell. We have an example here. So which of the arrows best shows the direction of the current in the wire? The choices states that it could be downward, upward, or rightward. So ano kaya? So here we are told that a potential difference is set up between the left and right ends of the wire shown. So the existence of a potential difference between 2 points means that electrons will tend to flow from one point to the other. In other words, there will be a current from one point to the other. In this case, since there is a potential difference between the ends of the wire, we know that this will create a current from one end of the wire to the other. However, we do not know which direction this will be, the right or the left. So this means the correct answer is the 3. Choice 3, the current will go to the right.
Here's the formula in computing electric potential difference. Electric potential difference is equal to electric potential at final point minus electric potential at initial point is equal to work to move Q from the initial point to the final point over charge that experienced the potential is equal to change in potential energy of Q between the initial and final points over charge that experienced the potential. Here's a sample problem. In an electric field, 0.90 joules of work is required to bring 0.45 coulombs of charge from point A to point B. What is the electric potential difference between point A and B? The formula we'll be using is voltage is equal to work done over charge. And the given are, work is equal to 0.90 joules, charge is equal to 0.45 coulombs. You just need to divide 0.90 joules by 0.45 coulombs and the answer will be 2 volts. The electric potential difference between point A and point B is 2 voltage.
Equipotential surface and field lines. An equipotential surface is a three-dimensional surface having the collection of points in space that are all at the same potential. Equipotential lines are the two-dimensional representation of equipotential surface. Equipotential surfaces are always perpendicular to electric field lines. The potential for a point charge is the same anywhere on an imaginary sphere of radius r surrounding the charge. So basically, ang ipinapahayag nito ay the surface which is the locus of all points which are at the same potential is known as the equipotential surface. No work is required to move a charge from one point to another on the equipotential surface. So for this slide, makikita natin sa baba shows that the equipotential surface and electric field lines for different charge configuration. The red lines are the electric field lines and the black lines are the equipotential surface. So for the first picture, the isolated positive charge, the electric field around an isolated positive charge is oriented radially outward because positive charge repel each other. So ang gusto lang illustrate ng picture that magsisimula siya sa positive charge at mag-e-end siya sa negative charge. So represented by lines of force or field lines. So for the second picture, the two like charges. Like charges refer to positive, negative to negative charge. Similar charge repel each other. Mangyayari lang ito, mag-a-attract sila kapag ang isa sa kanila ay mayroong pinakamalaki. Then the electrostatic force acting on the two is not due to their initial charge but will due to the charge produced due to induction and hence attraction takes place. So for the last picture, the two unlike charges, the electric field and resulting force created by two electrical charges of opposite polarity attract one another. For the similar charges, they attract each other.